Yes, sure. I hope you are able to see my screen. Can you see it?
Yeah, I can see.
Okay. Could you please read the question number 2?
In each question below, ABCD is a rectangle with AB equals to 2 and AD equals to 50. Point P is on BC and R is on AD. BR and AP intersect at S, and PD and RC intersect at Q as shown. If the area of PQRS is 6, determine the total area of the shaded regions.
So this is the diagram. Solution. The total area of the bottom two shaded region ASR and RQD can be determined by subtracting the area of the PQRS from the area of APD. I'll highlight the APD in a different color. So this is APD. So you're going to subtract that PQRS, the white portion,
Yeah,
from the APD triangle. Do you understand?
yeah,
Base length of APD is AD 15. From here to here it is 15. And height is equal to the AB, which is 2. And you know the formula for the area of a triangle, which is half into base into height. So you just have to apply that for finding the area of AB. Do you follow this part?
yeah.
The area of PQRS is 6. The total area of the two bottom shaded region is 15 minus 6.
How do we know the area of
We discussed
PQRS
earlier.
is?
We do have to subtract the triangle APD and the rectangle PQRS. I mean the quadrilateral PQRS. So which is 6. APD is 15. So if you subtract that, you want to get 9.
Yeah, but when did we
So
find 6? I think
your
that's what
voice
I
is
don't
too low.
understand.
Your voice is too low. How? Your question is how area of a PQRS is 6.
Yeah.
Okay. Given in the question.
Oh, okay. Oh, that's how they found it? Okay. And then the
Yeah.
top would be the same thing. It would also be 9.
Yeah. Is it clear?
Yeah,
So your
I
new
understand.
are getting that answer is 9. We can similarly show that the total area of the two top shaded region BSP and PQC can be determined by subtracting the area of PQRS from the BRC. Do you follow?
Yeah. Yeah, it's just the same triangle, just flipped.
Yes.
Yeah.
Yes. So we get 9. So 9 plus 9 would be 18.
Oh, okay.
1 second, Shana. From the question number 3, it's subdivision C and D, right? Okay. Could you please read the question number 3 for me? Shana, could you please read the question number 3 for me?
Oh, sorry, I was muted. For any positive integer with 3 or more different non-zero digits, let a cousin be defined as the result of switching 2 digits of the integer. For example, the integer 156 has 3 cousins: 516, 651, and 165. Suppose that C and D are distinct non-zero digits. The 3-digit integer CD3 minus one of its cousins is equal to the 3-digit integer D95. Determine the values of C and D and show that no other values are possible.
Five one six is obtained by switching the first and second digits. 6551 is obtained by 651 is obtained by switching the first and the third digit. 165 obtained by switching second and third digits. One five six one and 6 when you switch. I mean, first and second digit you're switching. Okay, switching, like you're swapping them. Okay. Okay. Are you able to follow this part?
Yeah.
The cousin of the 3-digit integers CD3 are DC3, 3DC, C3D. You're just applying the same logic.
Yeah.
Like how you're switching first and second, first and third, second and third, like that. Clear? So that you're doing here. The difference between the two integers, CD3 and DC3, could be negative. Could be negative. Let's try. Like 516 minus 651.
Oh yeah, it would be negative.
651 is obviously greater than 516. So when you subtract, it could be negative. Do you follow?
Yeah.
So they're saying that the difference between the two integers CD3 and DC3 could be negative, in which case it's not the right difference. If it is positive, then CD3 minus DC3 has one digit 0, thus cannot equal to D95. Okay, so let's break this one. CD3 minus DC3 has one digit 0 if it is positive.
Bye bye.
For example, 516651, right? Okay, let's try some different number, not an issue. You don't have to use the same number, we'll try different integer.
Yeah. Let's
Um,
do 1, 2, 3.
1, 2,
3.
3. So CD3 is 1, 2, 3, DC3 is 2, 1, 3, right? We're saying once a digit is 0. So we can assume like this. Like let's assume C is 2, D is 1. Okay. So CD3 means it's 213. DC3 means it's 123.
Wait, did they
So
tell us
now,
that D is greater than C is greater than D? Or did they tell us
okay.
that?
No, they didn't say anything like that.
Okay. No, because if
Let me check.
if
Let
D is
me check.
less than C, then it works.
Wait a minute. Let me check the question. They said it is non-zero integer, but they didn't give anything about the comparison.
Oh, okay.
So now if you subtract them, 213 minus 123, that would give you 100. So you are getting the units digit value is 0 here. Do you follow?
Yeah.
And they're saying, and thus cannot equal to D95.
Yeah.
D95 means the D was 195. Absolutely. Do you follow?
Yeah.
Similar. Can you try the second paragraph? Can you try the second paragraph for the same number and let's see whether this logic works for this or not.
Similarly, the difference between two integers CD3 and
3 and
C3D
C3.
could be
Yeah.
negative, which is not the right difference. Yeah, because if 3 3D is bigger than D3, then it will be negative and it will become a 2-digit number.
Yeah, you check whether you're getting hundredth digit as 0.
So if we have 2, in this case we have 2 1 3, right?
Yeah.
1 3
C is 2, 1 is
minus
D is 1.
2 3 1, which will be negative, right? Because 31 is bigger than, and also it won't be a 2-digit number.
You try some integer where you get the hundredth digit as 0. Excuse me.
Well, this one works because it's 2 minus 2. So you'll get 100 0.
CD3, C3D have the hundreds digit of C. Are you getting 2? Yeah. Like 2, 3, 1 minus 2 and 3 will give you. No.
It's 200 minus 200, so that's 0.
Okay. So 200 minus 200 means you are getting the hundreds digit as 0 here.
Yeah, or negative. Actually, it goes into the negatives.
So they're saying that in D9, 5 ones digit is 5 and C is 8. Can you try with this? Can you try with 8?
Okay. So the C's would be 8. So since the only way to get 1 digit 5 is 13 minus 8, right? So then you would have C. Oh, it's not letting me draw.
Excuse me.
Get 800 plus 10D plus
They are just
3.
rewriting 83
Yeah,
in terms
as like an equation. And then you get minus 300 minus 10D minus 8. And if you subtract, the D and D come out, and then you get 500, and then you get 495.
So 495 means the D should be 4. Do you follow?
Yeah.
So from that we can try whether 843 minus 348 is equal to 495 or not, because 843 is like CD3, C3D is 348. CD3 minus C3D can be written like this.
Yeah.
So C is 8 and D is 2.
Yeah.
We were trying with 2 and 1, right? Can you try the value of D is 4 and C is 8 for the first paragraph?
Well, if you have 8, 4, 3, and 4, 8, 3. Yeah, so in that case, you have one's digit is 0. So that doesn't work, right? That's what they said. And then so that's this one. And then if you do the next section, they're saying CD3, which is 843 minus 8, 3, 4, it would be 800, 800, and you'd only have like 9. There would be, that's not, D is not 0, so you can't have that. So then that's why we get this. So yeah, it works.
Okay. Excuse me. I think D is also similar. Suppose that M and N are distinct, non-zero digits. The sum of the 6 cousins of the 4-digit integer M97 is equal to the 5-digit integer NM7. Determine the values of NM and show that no other values are possible. M and N are distinct non-zero digits, so it must be from 1 to 9. Sum of the 6 cousins of the 4-digit integer M97 is equal to 5-digit integer NM7. Determine the values of M and N and show that no other values are possible. So here, 6 cousins of the 4-digit integer that first you need to find. So that is the NM97 can be written as NM97, 9NM7, 7N9M, M9N7, M7, 9N, and MN79. So now if you expand them, it will be 1000N, 100M, 90 and 7. They are expanding this one. And when you expand the second one, it would be 9 is 9 into 1000, N is N into 100, M is M into 10, 7 is 7 into 1. We've got it. So it's just an expansion of. I'm sorry. We follow the channel. I think you are muted.
Oh, yeah, I understand.
Now, you're finding the sum of, right. So sum means you just have to add these and these add like ones, hundreds, thousands, tens together. Can you try?
Okay.
You're just adding them. Are you getting the answer?
Yeah, I'm getting the answer on paper, but
Same answer. They're saying that the sum S must be equal to the 5-digit integer NM7, which has ones digit as 7 here. So ones digit of S is equal to,
MN
in
plus
this
30.
part, the last part is going to be the ones digit. Like this is going
Yeah.
to be the ones digit, right?
Oh, okay. I simplified all the way. That's why. Okay.
Oh, you have simplified. Like, did you get 28947?
No. I mean, I did all of this, like, I expanded. I didn't know they wanted us to keep in the digits. Okay.
Okay. No. You have to take them out
Oh, okay.
to try
So
to get
then I
this.
have the same answer.
Then you are having the same answer. Try to get this, okay?
Yeah.
So here m plus n is equal to 30.
So yeah, is equal
So
to. So,
nm7, which
so
means
7 is equal to
M
mn
plus
plus 3.
n equal to 7 means you're having 30 here. We're saying so m plus n would be 7 or 17 because the unit digit is 7. Do you understand?
Yeah.
One's digit of m plus n is 7 or 17. And here you have to write their possibility. 7 can be 1 plus 6, 2 plus 5, 5 plus 2, 6 plus 1, 3 plus 4, 4 plus 3. 17 could be 8 plus 9, 9 plus 8. You can't write 17 as 16 plus 1 or 15 plus 2 because they are two digits. Do you understand?
Yeah.
So now this is a bit difficult. You have to do trial and error only here. You can use calculator also. You have to substitute these value from the sum. In the sum, you have to substitute. Okay. So you have to substitute the value of m is 1 and n is 6 because you want to choose the first pair, which is 1 comma 6. So you are getting 2, 8, 9, 4, 7. 2, 8, 9, 4, 7. You have to check whether it is in the form of n, m, n, m, 7. So if it is correct, then it should look like this 28287 or 94947. We don't have neither. So we don't have either. So it's supposed to be the other pairs. So you have to try all the numbers. Try some random, try to pick 2 or 3 numbers and try to substitute here and check whether you're getting NM, NM7. Try 4, 3. That is the absolute solution. Try 4, comma 3 and you can try any one pair where you're not getting the exact sum. Just try to get some different one. Which number you want to choose? You can choose any pair.
We'll choose 2, 5.
2, 5. So here 3 into 2. You can use calculator also for solving it. Try with 4, 3 and this 2.